Okay, so in this video I'm going to do an example, but I want to also talk about some more terminology that you need to know. Okay, so whenever we have an angle where the initial side coincides with the x-axis and the terminal, the vertex coincides with the origin of the xy coordinate plane, the Cartesian plane, then we call this a standard angle, or standard position rather. Okay, so this is always standard position. The initial side always coincides with the positive x-axis with its endpoint, the vertex, located at the origin. And then of course the terminal side basically goes counterclockwise around the different around like a clock, okay, in the counterclockwise direction. So again, remember, this is positive side, going counterclockwise positive, going clockwise is negative. Okay, now, if we have an angle where the terminal side ends inside, let's say for example, quadrant 1, then we would call that a first quadrant angle. And likewise, if the terminal side ends in quadrant 2, we call that a quadra 2 angle, and so on, all the way around, right? Now, if the terminal side lands on one of the axes, okay, so if the terminal side either lands here, 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 or back here, we call that a quadrantal angle, okay? Which means that if it's on, for example, the y-axis, then we would not say that it is in either quadrant, okay? So, yeah, we wouldn't say we would not say it's in both. We would not say that it is in either one. It is called a quadrantal angle, okay? Now, what else do I want to say about that? So, let's see here. So the other thing too to keep in mind is that any angle is uniquely described by the angle. It's what we call the coterminant, the angle that it makes, the reference angle. So this would be the reference angle. Okay, theta, for example. So any angle, or excuse me, any point, right? Any point can be described by using an angle, right? So theta is in standard position. Okay, and the terminal side is uniquely determined by knowing that it passes through a particular point. Okay, now it doesn't pass through just that one point. In fact, there's an unlimited number of points, but knowing that the terminal side passes through any one point makes it possible to determine what the terminal side of the angle. Okay, so again, all we need to know is a point on this terminal side, and we can always describe and find what that terminal side looks like. Okay. Let me see, should I do an example? No, I can just show you. So, in this case here, I could have 60 degrees. Yeah, let's do 45. That's more like 45 degrees. So I can have 45-degree angle. And I could say that this point here is 3, 3. Okay, right? So as soon as I have the point, I can always describe the angle or the terminal side that goes through that point. Okay? Or I could say it goes through 4, 4, or 1/2 and 1/2, or 10, 10, right? Any one of those would work. And this would be a quadrant 1 angle, as opposed to if I had something like this, right? Which would be 270 degrees, and this would be what we would call a quadrantal angle. So I didn't really make that too good, but like that. Okay. Or I could do negative 90 degrees, right? Okay, that's it. That's all we have for today. Have a great day.